class. Is there too much reflection of light? No, right? I told you guys to tell in your groups where CP pupil, where are your friends? Only one guy. Good morning, where are your friends? Only you are in the live. Good morning, good morning. Only two people. Where are others? Three. At least 10. At least 10 will start. Okay. Like yesterday. At least 10. Four. How are you doing all? Good morning. So today we are planning to do Ionic in one shot, and there is a bad news that you have physics class at 11. Is it correct? Is it correct or wrong? You have physics at 11. We will try to stretch as much as possible. अपन बड़े अपन बाद में भी करेंगे. हाँ, बाद में कब करेंगे? बाद में तुम लोग आओगे नहीं क्या स्कूल? सॉरी, कॉलेज. वैसे तो तुम स्कूल ही हो, बट आओगे नहीं क्या कॉलेज? So as we discussed yesterday, you have completed your NCRT and you have your note. You have your note beside you. Then only we can start. All of you have your note beside you. Note. So ionic equilibrium. Ionic equilibrium. Why only 6? Why not 60? Like first two classes we got 60 attendance. What happened to others? What happened to other people? Why not 60? Why only 6? Array, only 8. So please, at least 10. At least 10. Share in your WhatsApp groups. At least 10. Okay, now 10. So we'll start now. What is ionic equilibrium? Can anybody say ionic equilibrium is applied to weak or strong? Ionic equilibrium is applied to weak electrolyte or strong electrolyte? So we have two types of electrolytes, right? Weak and strong. So for strong electrolyte, alpha is equal to 100% or 1, right? So all the particles will dissociate. What are the strong electrolytes? Strong base, strong acid, and all salts. We know this, right? All the strong electrolytes. Then what are the weak electrolytes? Where alpha is very less than 1, means 5%, up to 5%. where alpha is up to 5%, maybe 1%, maybe 0.1%, maybe 0.001%. So here all weak acid and weak bases like formic acid and Na4OH, right? So we know what is weak acid, what is strong acid, what is weak base, what is strong base. And then for ionic equilibrium, as we discussed earlier, we will discuss only about weak electrolytes, because strong electrolyte will completely dissociate and it will not stay in equilibrium. So weak electrolyte will stay in equilibrium. So let us consider HCOO minus plus H plus. So this is, let's say, 5% dissociation. So we have 95% of unused or 95% of unionized acid, and we have 5% of ions. So for a weak electrolyte, when the ionization is very less, we'll have 95% of unionized compound and 5% of ionized compound. So there will be a very good definition for ionic equilibrium. Well, there will be a very good definition from ionic equilibrium. So ionic equilibrium can be defined as the equilibrium which is established between, ionic equilibrium can be defined as equilibrium established between unionized molecules. Here we have unionized molecules. So unionized molecules and ionized ions of a weak electrolyte. Always for a weak electrolyte, not for strong electrolyte. So in ionic equilibrium topic, we will only consider weak electrolyte, not strong electrolyte. So please take a grab a screenshot. Then we will proceed to our next topic, acid base theories. So in ionic equilibrium we studied in two parts, right? First one is acid base theories and second part is our Ostwald's law and pH. Okay. So let's see about acid base theories. If you have not taken the screenshot, please go back and take the screenshot. So in acid base theories, our first theory was Arrhenius theory, acid base. So first theory was Arrhenius theory, right? What Arrhenius said? Acid is a, what Arrhenius said? Acid is a, अरे बोलो, acid is a H plus donor, base is a OH minus donor. So what about the examples? Do you know? HCl, H2SO4, H3PO4, correct? What about the bases? NaOH, KOH, MgOH whole 2. So all of them who can produce H plus and OH minus. So all strong acids, strong bases, weak acid, weak bases. Right? All will come in the Arrhenius category who can produce H plus and OH minus. Got it? So we all know what is Arrhenius theory. No need to take a screenshot. So let's go to the limitation, from where the questions will come. Limitations. And there will be questions about which is Arrhenius base, which is Arrhenius acid. Okay, but those questions are very rare nowadays in JEE mains. Only for NEET purpose these small example questions are there. But in JEE you will get, what you will get? Limitations. So first of all, Arrhenius told that it is in aqueous solution. So what about dry? What about dry HCl? Is it acidic or basic? Dry HCl. Is it acidic or basic? Comment box, guys. Comment box. Yes. Good morning. So what about dry HCl? Is it acidic or basic? What about compounds not having H plus and OH minus? So what about all these compounds? So first let's discuss about dry HCl. Is it acidic or basic? Dry HCl. Anybody? So Arrhenius said that only in aqueous solution, a acid or base will dissolve or decompose and give us acidic and basic nature or H plus and OH minus. But what about dry? Dry means without any water. What about dry HCl? So it is a limitation. It is really acidic, very strong acid, but it is a limitation of Arrhenius theory. Then what about SO2 and CO2? These are acidic oxides. But Arrhenius told that acids should give H plus ion, but they don't have any H plus ion, right? But these are acidic, so it comes under limitations or drawbacks. Similarly, base should give a OH minus ion, but here there is no OH minus ion in NH3 or PH3, so these are basic, but limitation or drawback of Arrhenius theory. Similarly, AlCl3 and FeCl3, both of them are Lewis acid, but Arrhenius didn't explain that because it cannot give H plus ion, so they are not acid, correct? So these are all limitations of Arrhenius theory. Please take a screenshot if you have not. Limitations of Arrhenius theory, right? Pause and take a screenshot. Then what is the second theory of acid base concept? Bronsted and Lowry theory, where we will get the conjugate acid base concept. So that is also very important. Bronsted Lowry theory. Okay. So what Bronsted and Lowry told? Can anybody say what is the acid? What is the acid according to Bronsted and Lowry? What is the acid according to Bronsted and Lowry? Guys, what is the acid according to Bronsted and Lowry? Acid is a H plus ion donor. What is the base according to Bronsted and Lowry? H plus ion acceptor. All of you forgot. No response in comment box today. 21 people live, but no response. So what about acid? Let's say we have an acid Ha, which reacts with water. So what will happen in equilibrium? This acid will give H plus and water will become H3O plus, right? And we know water is amphoteric. So it can act as acid and base. So water is amphoteric. It can act as acid and base. So this is a acid. This is a base. So if this is a acid, this will. If Ha is a acid, A plus will be. If Ha is a acid, A minus will be. If Ha is a acid, A minus will be conjugate base, right? We know Bronsted and Lowry suggested about acid base pair. Similarly, if water is a base, then what will be H3O plus? Conjugate acid, right? If water is a base, H3O plus will be a conjugate acid. So this was the overall thing about Bronsted and Lowry theory. Then what is the difference? What is the difference? Difference between an acid base pair. Difference between a conjugate acid base pair. What is the difference between a conjugate acid base pair? Can anybody say? Can anybody say what is the difference between conjugate acid base pair? So CP pupil, that is one proton. If acid can donate one proton, it will become its conjugate base. If base can accept a proton, it will become its conjugate acid. So there is a difference of one proton between conjugate acid base pairs. Okay, correct. So this is the basics of Bronsted-Lowry theory. Let's see some examples. You know what is amphoteric, right? I don't need to write anything. So let's see. If a acid H is dissociating in presence of water to give us H plus and A minus, what will be its Ka? K is acid constant, right? And what will be BOH? BOH is a base which can dissociate as B plus and OH minus. So what will be Kb here? So are you familiar about K and Kb? So this is an acid, this is a base, this is Ka, this is Kb. So Ka is acid constant, Kb is base constant, right? This will be product by reactant, B plus OH minus divided by BOH, and this one will be also product by reactant, HA, H plus, A minus. So how to calculate pH? Can I take all this side and I will get H plus? How to calculate pOH? Can I take all this side and I will get only OH minus concentration? Correct? So can I take minus logarithm of all of them to get my pH and pOH, to get my desired pH and pOH? So let's see. We know what is Kw, right? We know what is Kw, ionic product of water. Ionic product of water is H plus into OH minus. At 25 degrees centigrade, it is 10 to the power minus 14. At 90 degrees centigrade, it is 10 to the power minus 12 approximately. Okay. So we know what is Kw, Ka, Kb. So these are three important terms we will use repeatedly in ionic equilibrium. Okay. So don't forget them. Then we will get Kh, Ks, P and all of them. So buffer. So take a screenshot, grab a screenshot if you want. You can go back also and watch again. It's up to you, right? Then what do we have? What else we have? 22. Now only 22 live. So it's a good number compared to yesterday night, right? Yesterday we only have around 5 to 10 people. It's a very good buffer. We'll go one by one. So now we are at Bronsted and Lowry theory. We'll go one by one. So what is the limitations? What are the limitations of Bronsted and Lowry theory? Limitations of Bronsted and Lowry theory. Limitations of Bronsted and Lowry theory. Anybody? Can anybody say what are the limitations of Bronsted and Lowry theory? What are the limitations of Bronsted and Lowry theory? Can anybody say? Can anybody say what is the limitations of Bronsted and Lowry theory? Yes. What are the limitations? So in presence of a strong acid, another acid acts as a base, which is not correct, right? In presence of a strong acid, another acid acts as a base. So this will be ClO4 minus and HF2 minus. So this is the limitation. This is also acid, this is also a acid. But in presence of a strong acid, the weak acid acts as a base. So in presence of a strong acid, the weak acid acts as a base. So this will be conjugate base and this will be conjugate acid, right? This will be conjugate acid. So similarly, H2SO4 and HNO3 will act as base in presence of strong acid. So in presence of strong acid, these very strong acids are also acting like a base, which is not correct, right? These things are not correct, right? So which is not correct. So these are the limitations of Bronsted and Lorry theory, and you will get definitely you will get one or two questions from limitations. So please carry on. At least if you don't get this in final exam, you will get in your test series. So don't ignore them. Don't ignore any part in ionic equilibrium because maximum of them are important. Acid base theories, buffer, solubility product, and salt hydrolysis. All of them are important, and we will study indicator offline. We will study indicator offline. Then. So Bronsted and Lorry theory is overall completed. Then we will come to solvents. Solvents are of two types, right? We discussed in our class. This is protic solvent. This is aprotic solvent. Protic solvent means which gives H plus ions. So all acids, water are protic solvents. Aprotic solvents which cannot give H plus ions. Then in that also we have non-polar, polar, and we have highly polar. Okay, so in non-polar we have CCl4, carbon tetrachloride. In this category we have DMSO, DMF, middle category. THF we have tetrahydrofuran. Then highly polar are interhalogen compound BRF3, BRF5. Right? We discussed in your class BRF3, BRF5. क्या बोल रहे हो बेटा चार्ट्स में? अरे love you brother. So let's see. Love you brother. So protic and aprotic solvents. Advance happy birthday. Yes, thank you. Love you all. So we got what is protic and aprotic solvents. So no doubts about solvents, right? So we can decide which is protic, which is aprotic. Whenever you say we can see a proton in any solvent, we can see a proton, that is a protic solvent. If we don't have anything out of that, but there are also aprotic solvent which cannot produce a proton, can be non-polar like CCl4 or THF, or can be moderately polar like DMS or DMF. We have discussed all the structures, so don't ask again. Then it will be highly polar, BF3, BRF3 or BRF5, interhalogen compounds which are highly polar. So can we clear? Only 30 people. So let's go to the third acid base theory, Lewis concept. Lewis theory. What Lewis told, acid is a, what Lewis defined, acid is a, can anybody say what Lewis defined? Can anybody say what Lewis defined? Acid is a, guys, why are you dead today? Why are you all dead today? So Lewis said acid is a electron pair donor and base is a electron pair acceptor, right? And we get coordinate bond in between them. So NH3, consider, yes, NH3. NH3 will be a Lewis acid and BF3 will be a Lewis base. Why NH3 is a Lewis acid? We discussed, right? Yes, very good, Sahasra, very good. So this is a electron pair donor, electron pair or lone pair donor. This is a acceptor. Why acceptor? It has vacant orbitals, right? So we'll study about orbitals. I think you have studied in atomic structure. We'll again study in we'll again study in chemical equilibrium and periodic table. So what will happen? Now this Lewis base will coordinate with the Lewis acid BF3 in a coordinate bond. Okay, we'll form a coordinate bond. So which one is our Lewis base? This part. This is our Lewis base, which can donate a pair of electrons, and this is our Lewis acid. We write it as a La and Lb. So Lewis acid, which is electron pair acceptor. So there are a lot of examples we have discussed. We have also discussed about coordination compounds, for ionization constant of formation, ionization constant of dissociation. All of them we have discussed. So let's go to the limitation. Let's go to the limitations of Lewis theory, which we will expect in exams. So limitations, all the neat people who are there, so please take care about the limitations of Lewis theory, because it is always asked. So limitations of Lewis theory, what is there? So Lewis theory didn't explain about relative strength, right? About relative strength of acid and base. Relative strength of acid and base, right? Which acid is stronger, which acid is weaker? It didn't explain. Lewis acid, HCl, H2SO4. They cannot do any coordinate bond, right? They cannot do any coordinate bond. But they are acid, right? They are very strong acids. They are very strong acids, but they cannot do any coordinate bond. So this is a very big limitation. Similarly for strong bases, NaOH, KOH, they are very strong bases, but they cannot do any coordinate bond. Yes, good morning, good morning. So again, what is the last limitations of Lewis theory? Last limitation will be neutralization. Neutralization is an acid-base reaction. Neutralization is very fast, right? But coordinate bond formation, which Lewis theory suggests, is very slow. So suggesting a very slow pathway for acid-base reaction is also very abrupt. Okay. So in some cases, Lewis theory is correct, where it is explaining about species which are not having any H plus and OH minus. So AlCl3, FeCl3, it is correct about all of them. It is correct about NH3, BF3. So Lewis theory is correct about all of them, but not correct about the traditional acid and bases, which Arrhenius and Bronsted and Lowry suggested. But Lewis theory is correct about non-traditional acid and bases, like where we don't have H plus and OH minus ions, right? So please take a screenshot. So Lewis theory is almost revised by all of you. Hopefully you have completed your NCERT, otherwise there is no meaning. If you don't have your NCERT and notes, there is no meaning you are coming to this class. Okay. So let's go to the next topic. So Locks and Flood concept and Usanovi concept. ये देख लेना आप लोग. Okay, Locks and Flood and Usanovi concept. You can revise. Can you revise? Yes or no? You can revise, right? Can you revise Locks and Flood and Usanovi concept? Yes. Very good. Then let's go to the hard and soft acid base rule. So hard and soft acid base. Hard, बहुत hard. And soft means बहुत soft. Acid base. So बहुत hard acid base में कौन जाएंगे? We will go in hard acid and hard bases. Ha, Hb. So hard acids will be all the transition metals, lighter, Fe, cobalt, chromium, along with hydrogen. So all lighter transition metal ions. Lighter means 3D series. So all lighter transition metal ions. All lighter transition metal ions मतलब जिनका वजन कम होगा. So lighter transition and metal ions will come in the category of hard acids. So what about the hard bases? So hard bases will be very strong Lewis bases like this water can donate lone pair, ammonia can donate lone pair, BH3 can donate lone pair, right? F minus, you can say F minus, F minus. Okay. Then what about soft? Soft acid. Soft acid, not strong acid, and soft base. So not strong acid and strong base, it's soft acid and soft base here. So what will have in soft acid? All the ions Pd2 plus, copper 2 plus, zinc 2 plus, Hg2 2 plus, gold plus, silver plus, all of them, all heavier transition metals. All heavier transition metals are soft acids. Similarly, what are the soft bases? PRP, the phosphorus compounds, the thioethers, R2S. Okay, thioethers, R2S and phosphorus compounds will come under this category. Okay, and carbonyl Cn minus will come in the soft base category. Carbonyl Cn minus. Here, large size and less electronegativity. So we'll study all of this in periodic table. So electronegativity, large size and less electronegativity makes them soft base. So please take a screenshot if you don't have this part. So you have hard base, which are our Lewis bases with lone pairs F minus, Cl minus, which can donate electron pair. Then hard acid is the lighter transition metals which can accept electron pair easily, like Fe plus, Fe3 plus, cobalt 3 plus, chromium 3 plus, H plus, like. Then what about the soft acids? Soft acids are heavier transition metals like palladium, platinum, copper, gold, silver, zinc, mercury, all the precious metals. So they come in the soft acid category. And what about soft bases? PR3, thioether, R2S, CO and Cn minus. All of them which have very big size, like bigger size and less electronegativity. So we know, right, down the group size increases. So nitrogen is smaller and phosphorus is bigger, right? Sulfur is bigger, oxygen is smaller. We know, right? So these two, oxygen and nitrogen, come in hard base category, and sulfur and phosphorus come in soft base category. Are you understanding? Yes. Very good. So this completes our acid base concept. Then we'll go to the main ionic proper. So before that, I will give you a very small question. And we have discussed that earlier. I will give you a very small question from this concept. We have discussed that earlier also. Order of acidity or order of acidic strength for halogen acids. So HF, HCl, HBr, HI. So what will be the order of acidic strength between all these halogen acids? HF, HCl, HBr and HI. Can anybody answer this? Order of acidic strength. Nobody can answer this. CU, okay. Yeah, CP people, very good. Yes. So HCl is strongest. Mansa? No, it's not correct. I have asked the order, like in less than or greater than, right? You have to put less than sign or greater than sign in between. So HCl is a strong acid, no doubt. No doubt HCl is a strong acid. But what is the order between them? HF, HCl, HBr, HI. So very interestingly, HCl is not the strongest in the batch. The strongest is HI. Strongest acid. Okay, because the large size of iodine, I minus ion, large size of I minus ion is not that much compatible with the H plus, so it will release the proton very fast, right? So which will be a stronger acid, which will release the H plus fast. So iodine will release the H plus fast, HI will release the H plus fast. So that's why H plus will be, HI will be the strongest acid, then HBr, then HCl, then HF. So HF is the weakest acid among these. HF is the weakest halogen acid. Halogen acid means compounds of chlorine, iodine, bromine, right? We know what is halogens, group 17. So weakest halogen acid is HF. Correct. So take a screenshot. Lot of you are confused in this concept. It's a very easy concept. All of you are confused in this. So please take a screenshot. Yes. What you are deleting, beta? What you are deleting? Why you are deleting? Okay, message retracted. क्या कर रहे हो आप लोग? हैक तो नहीं कर रहे हो स्ट्रीम को? लाइव स्ट्रीम को हैक तो नहीं कर रहे हो आप लोग? करो आराम से करो, हैक करो. So थोड़ा सा वाटर ब्रेक लेते हैं 2 मिनट का, फिर आगे कंटिन्यू करेंगे अपना नेक्स्ट पार्ट. जहाँ से शुरू होगा Ostwald's law of dilution, then we will jump into buffer, right? pH and buffer, then solubility, okay, then our final chapter, salt hydrolysis. So we will complete that. So चलो Ostwald's law is applicable for, you will tell, is applicable for Ostwald's law is applicable for weak electrolyte or strong electrolyte? Ostwald's law is applicable for, कोडिंग नहीं आना भी चाहिए आप लोगों को. So Ostwald's law is applicable for weak electrolytes, right? Only for weak electrolytes. Where are others? So Ostwald's law is only applicable for weak electrolyte, and see it says alpha is equal to root over of K by C. K may be Ka or Kb for weak acid or weak base. For weak acid Ka and for weak base Kb, right? Which will be also equal to K into V, because we know concentration is inversely proportional to volume, right? So this is the Ostwald's law of dilution. No need to remember any statement. You will be asked questions from here. And we are applying Ostwald's law everywhere. To get the final results, right? So there is another interesting concept about isohydric. Isohydric solution. Isohydric. So please note it down. Isohydric solution. When the concentration of the common ion. You know what is common ion, right? Common ion is same. So when the concentration of common ion is same, the solution is called isohydric. And what is the formula there? Now Ka1, if two acids are added, Ka1 by Ka2 will be C1 by C2, concentration of two acids. So two weak acids are added in an isohydric solution. If the common ion in the two weak acids have similar concentration, then the Ka1 by Ka2 will be C1 by C2. Sorry, C2 by C1, C2 by C1, C2 by C1, C2 by C1. So write down this. Very important formula. Sir, क्या बोल रहे हो बेटा? Sir, that's nice idea. सर आपका हैंडमेड नोट्स ऑफ दिस पर्टिकुलर चैप्टर का पीडीएफ डिस्क्रिप्शन में पिन कर दो ना सर. इट विल बी मच हेल्पफुल. मैथ सर डज दिस थ्रू टेलीग्राम सो वी कैन रेफर इट बाय प्रिंट आउट्स. अरे मेरा हैंडमेड नोट्स का ओके कर सकते हैं विल डू. मेरा हैंडमेड नोट्स भी दे सकते हैं आप लोगों को. बिल्कुल. सो मेरा जो नोट्स रहता है बहुत कंसाइज रहता है. मैं पूरा इतना ज़्यादा कुछ नहीं लिखता. यहाँ जितना भी पढ़ा है वो स्क्रीनशॉट अगर आप ले लोगे तो वही हो जाएगा अपना नोट. ओके, सो दिस विल बी ओनली अवर नोट. सो हैंडमेड नोट का कंसाइज आपको देंगे, जरूर देंगे, क्यों नहीं देंगे. टेलीग्राम पे ले सकते हैं आप लोग, यूट्यूब में भी ले सकते हैं, कोई बड़ी बात नहीं है. ड्राइव में अपलोड कर देंगे, आप वहां से डाउनलोड कर लेना. So isohydric solution, very important. Don't miss that. Go back and take a screenshot. Then we will go to the pH. Now you know what are the pH, right? pH for strong acid, strong base, weak acid, weak base, mixture of weak acids, mixture of weak bases, mixture of strong acid, weak base. Okay. So let's see what are the pH formulas we have, right? pH for a strong acid, H plus ion concentration, right? So if you know this H plus ion concentration for a strong acid, pH will be minus log H plus, right? For a strong base you will calculate pOH, then you can convert pOH into pH. I am not interfering in that, because we know pH plus pOH is equal to 14 at 25 degree centigrade. Similarly for a weak acid, pH will be pKa minus half log C, right? pKa minus half into half pKa minus half log C. Similarly for a weak base, pH is equal to pOH is equal to half pKb minus half log C, where C is initial concentration of weak electrolyte, initial concentration of weak. So we know all these formulas, just revision. We know all these formulas, just we are revising again. Sir, your video is blurred. No, now it is not blurred. Please check. Please increase your video quality a bit. Video is not blurred. Is it blurred anymore? So all of you know all the derivations. How we got the pH for weak electrolyte, how we got the pH for weak acid, right? Then come to important formulas. Mixture of a strong acid plus weak acid. Let the concentration of strong acid is C1 and concentration of weak acid in C2. So the H plus ion concentration will be C1 plus root over of C1 ka square plus 4K1 4KaC2 divided by 2. So what is Ka? Acid constant. For acid constant is calculated for weak acid only, right? Strong acid will not have any acid constant. So in this way you will calculate the H plus ion concentration. Then to calculate pH, we have to do minus of log H plus, right? Minus of log H plus ions. Correct or wrong? So if we are mixing a strong acid with a weak base, our formula for H plus ion concentration will be C1 plus C1. C1 is concentration of strong electrolyte and C2 is concentration of weak electrolyte. So C1 plus root over of C1 square plus 4Ka1 plus 4KaC2 divided by 2. So here pH is equal to minus log H plus and Ka is acid constant of a weak acid, right? Acid constant of a weak acid. Correct or wrong? Got it? Is this easy? So what will be the mixtures? So we can add HCl plus COOH. We can add H2SO4 plus COOH. So while adding H2SO4, what concentration you will use? Normality, right? You have to use normality. Always in every pH formula, you have to use normality and concentration will be given in molarity. So how will you convert? N factor into molarity. Normality will be N factor into molarity. So very good revision. So you can try all the questions. I gave you the one short lecture. Please take a screenshot. Go back and take a screenshot. Take a screenshot, guys. So then we have to calculate the pH for the mixture of weak acid. So if we are adding 10 or hundreds of weak acid together, so weak acid, mixture of weak acids. So what will be the pH? The H plus ion concentration will be root over of Ka1 C1 plus Ka2 C2, okay, plus Ka3 C3. If we have three weak acids having acid constant as Ka1, Ka2, Ka3 and their initial concentration as C1, C2 and C3. So this is the H plus ion concentration. Then you can calculate the rest, right? Similarly, POH for weak base mixture. So let's add three weak bases having Kb as Kb1, having base constant as Kb1, Kb2 and Kb3. So OH minus ion concentration will be same. So root over of Kb1 C1 plus root over of Kb2 C2 plus root over of Kb3 C3. Right? So please note down. Then you can calculate, right? You can calculate. Just take minus logarithm, minus log of OH and minus log of H plus to get the pH and POH, and you can convert the vice versa, right? pH plus POH is equal to 14. So I don't need to tell that repeatedly. Every time I don't need to tell that, right? So take a screenshot. These are very important formulas and it will help you solve problems in seconds. It will help you solve problems in seconds. Then for a mixture of strong acid and strong base. So for a mixture of strong acid and strong base, acid base mixture we'll study again strong acid and strong base. So here we have to calculate number of equivalents. Number of equivalents is N1 into V1 means normality into volume in ml, volume in liter. Okay, then if you want to calculate milliequivalents, that will be normality into volume in ml, right? And if you want to calculate the final concentration, that will be N1 V1 plus N2 V2 divided by V1 plus V2. So the final concentration or final normality will be N1 V1 plus N2 V2 divided by total volume. So if you want to convert it into molarity, M3, let's see what will be the molarity. M3 will be, first you have to calculate N factor. So N1 M1 V1 plus N2 M2 V2 divided by N3 into V1 plus V2, where N is N factor. N factor we know, right? N factor we know. So what is N factor for acid? Take a screenshot. So it's a strong acid plus strong base titration. Titration or neutralization, right? It's a strong acid and strong base titration or neutralization where N3 is equal to N1 V1 plus N2 V2 divided by V1 plus V2. Again we know normality is equal to molarity into valence factor. So normality is equal to molarity into N factor. So I have multiplied N factor here. So N1 V1 will be N1 small N1 M1 V1 and N2 V2 will be small N2 M2 V2. So this will N3 will be divided here and we'll get the final molarity. We can get the final normality. It's important and this is also very important. Final molarity. So please take a screenshot. Please take a screenshot of this strong acid, strong base type of calculation. Okay. Thank you. So let's go to the important part, buffer solution, then solubility product, right? So do I need to share about N factor again? You know what is N factor, right? Do I need to discuss about N factor again? Do I need to discuss about N factor again? No, right? So let's go to buffer. What is a buffer solution? Which can make the pH constant up to some extent, right? Which can make the pH constant up to some extent. So acidic buffer and basic buffer. So this can make the pH constant up to some extent. Right? Up to some extent means up to addition of small amount of acid or base. Acid we denote as H plus and base we denote as OH minus. So what is acidic buffer? Weak acid plus salt of that weak acid with a strong base. So let's consider example HCOOH plus HCOONA. This is a direct acidic buffer. Then what will be the indirect acidic buffer of this example? Just add with the base. So what was the condition for indirect buffer? What was the condition of indirect buffer? What was the condition of indirect buffer? Anybody? So to be indirect buffer, we need more amount of acid. So concentration of this acid, weak acid, will be greater than the base, strong base. Okay. So similarly, in the basic buffer category, you can say weak base plus salt of that weak base with a strong acid. So NH4OH plus NH4Cl, which is a salt of that weak acid with HCl, correct? Similarly, this is direct. What will be the indirect one? NH4OH plus HCl. What is the condition? This base must be greater than the concentration of the base, or the normality of the base must be greater than the acid. So always consider normality. Normality is equal to molarity into valency factor, and you know what is valence factor. I don't need to discuss about L factor again and again. So this is the buffer. So let's go to the pH of the buffer. Buffer pH formula, right? You know the buffer pH formula, right? Henderson-Hasselbalch equation. So let me erase this part. Let me erase the example part. If you have not taken a screenshot or you want to take, so you can go back and pause the video and take. Right? So what will be the pH here? You have to calculate pH for the acidic buffer. It will be pKa plus log concentration of salt by acid or pH is equal to pKa plus log, that salt can be conjugate base, right? Conjugate base of this acid, concentration of the conjugate base divided by acid. So very important. What will you calculate on this side? POH, right? POH will be pKb plus log salt by base. pKb plus log conjugate acid concentration divided by base concentration, right? And you know the log values, and you know the pH and pOH relation. So this is called Henderson-Hasselbalch equation. So these are called Henderson-Hasselbalch equation, right? These are called Henderson-Hasselbalch equation. So please take a screenshot. This is the all formulas for buffer you need to know, and you have to put the concentration. This concentration is normality always, or you can just convert according to normality every time, because if you are releasing 2 moles of H plus or 2 moles of OH minus from acid or base, that will be the problem, right? Okay, so please consider that also always. Every time you have to consider that. So N factor is very important to solve this type of problem, and I think all of you are aware of the log values also, right? So let's go to the solubility product part, and last part will be our salt hydrolysis. So solubility product and solubility for different types of salt. We have different types of salt: AB2 or A2B. We have AB3 or A3B. We have A2B3 or A3B2. We have AB4 type or A4B type, right? We have a lot of type of this. So what is the general formula of KSP solubility product? What is the general formula? X to the power x, y to the power y, and s to the power x plus y. What is the small s? Solubility. And these are the types of salt. So every type means NaCl, right? Here PbCl2. Okay, here Ag2, Ag2SO4, right? Okay, similarly here AlCl3, right? Here Al2SO4 whole 3, right? Here CCl4, CCl4 is non-polar, so don't consider that. Here it will be SiCl4, okay, all of them. So so what will be the KSP here? 1 to the power 1, 1 to the power 1, s to the power 1 plus 1. So s square. What will be the KSP here? 4s cube. What will be the KSP here? 27s to the power 4. This will be 108 s to the power 5. And this is a very interesting example. 4 to the power 4 and s to the power 5. So 4 to the power 4 is 4 to the power 4. 16 into 16. 16 का square कितना? 200 something, right? 256. Okay. Correct. So here we have two types of salt. One is completely soluble salt. All nitrates are completely soluble and sparingly soluble. So we study KSP for sparingly soluble salt. KSP is studied for sparingly soluble salt, which is AgSO4, AgCl3. Okay. So take a screenshot of this. Take a screenshot of this. You know all these formulas, right? So let's discuss about a reaction. So let's see, AXBY is dissociating and it is a sparingly soluble salt. It is dissociating in water. So it will be x a to the power y plus y b to the power x minus, right? So here if the solubility is Sx, here y is, so what will be the KSP? It will be a to the power x and b to the power y, right? So xs to the power x and ys to the power y. So we will get our final formula, x to the power x, y to the power y, s to the power x plus y, right? And similarly, this KSP is calculated at equilibrium. KSP is calculated at equilibrium. Correct or wrong? KSP is calculated at equilibrium. So all of you are correct. So if I calculate this same thing other than equilibrium, then this will be KIP, ionic product. This will be KIP. And you know the condition for precipitation, right? You know the condition of precipitation. So can I erase? So the conditions for precipitation. So first case, let us consider first case. KIP is less than KSP. Means reaction in forward direction. Reaction is in forward direction and yet to be completed, yet to reach equilibrium, right? Then what is the second case? KIP is equal to KSP. So this reaction is at equilibrium, correct? KIP greater than KSP. This was our desired case. What was our desired case? Now we will get precipitation here, PPT, because ionic product is more than solubility product. So whatever the extra product is formed will come out as, whatever the extra product is formed after equilibrium will come out as precipitate. Okay, will come out as precipitate. So this is all about buffer and solubility product. So last part is remaining, salt hydrolysis. Then we'll discuss indicator when you come live tomorrow. Okay, we'll discuss indicators when you come live tomorrow. So salt hydrolysis, you know, it's a very recent topic. So you cannot hydrolyze salt, strong acid and strong bases. So we have only three options: weak acid plus strong base, right? For the salt hydrolysis of weak acid and strong base, what was the hydrolysis constant or degree of hydrolysis? What was the degree of hydrolysis? Tomorrow college is not there. Yes. yes, very good CP people. Bastavaria college is there. Discuss few numericals. Okay, numericals we discuss. So first let's complete the one shot. So what is the H here? KH by C, and KH is equal to KW by KA into C, right? Then what will be the pH? pH will be 7 minus half pK minus half log C, right? So 7 plus half pK plus half log C, because this is a weak acid and strong base, so pH should be greater than 7. So you will remember this formula easily. Second one is weak base plus strong acid. Weak base plus strong acid. So here we'll have Kb and we have to calculate KOH. So H will be KH by C and you will get KW by KAB into C. Then what will be the pH? 7 minus half pKb minus half log C. What happened? Now here pH is less than 7 always. Then what is the third case? Third case is weak acid plus weak base. Right? Hydrolysis constant will be root over of KH only, and KH will be root over of KW by K into KB. Why both? Why both? Because we have weak acid which gives us K, and we have weak acid, weak base will give us KB. Then what will be the pH formula here? 7 plus half pK minus half pKb. So yesterday we have played with this. If pK is equal to pKb, solution will be neutral. So all of this summary of salt hydrolysis. All of this is summary of salt hydrolysis, and hopefully you all understood. You all understood this much. Okay, so please take a screenshot. I am getting out of your way. So please take a screenshot and make a formula booklet. Formula booklet is very important for physical chemistry. You have to keep all your physical chemistry formula. So explain last one. So here we have two components, right? Weak acid and weak base. So we will have KH is equal to KW by Ka into Kb. Both weak component will be divided, not only one. And the pH will come as 7 plus half pKa minus half pKb. Okay, yesterday we have derived 1 hour lecture. Sorry, day before yesterday. So you can check that lecture. Ionic equilibrium class 2 online. It's there for 1 hour. You can check that lecture. It's already in the channel. Then. So our next class will be about indicators and pH curve. So very important topic, very difficult topic to understand. But once you understand, you will not leave any question. Once you understand indicators and pH curve, you will not leave any question. So first, we'll discuss about indicators and pH curve in the next class. Then we'll go to the ionic equilibrium questions. And we have some acidic strength, basic strength orders, acidic and basic strength orders. But those are completely inorganic topics, so we will cover them in inorganic chemistry. We will cover them in inorganic chemistry, especially periodic table and P block, S block. So we will cover them in periodic, P block, S and P block. Okay, we'll cover them there. So don't worry about the orders. Next class will be on indicators and pH curves. So hopefully all of you enjoyed this one short video where everything is summarized from beginning, from the definition of ionic equilibrium to the salt hydrolysis, coming through Ostwald's law, acid-base theories, then hard acid, hard base, soft acid, soft base. Then we went to buffer formulas, then we went to solubility, then we ended with the salt hydrolysis formulas. So last class will be indicators and pH curves, which is very interesting, very tricky to understand, but once you understand, you can solve any type of problem on this concept, because problems are easy from here, but the concept is tricky to understand. So I will take the next class tomorrow, and if you want to say anything, you can type in the comment box. We'll discuss for 2-3 minutes, then we'll go. Yes, make edu offline. No beta, first and third formula are not same. Make edu, please check your notes. Whoever is make edu, please check your notes. First and third formula is not same. How can be weak acid, strong base and सर पांडे सर नहीं आएगा, मुझे पता नहीं, पांडे सर को पूछो। आप केमिस्ट्री के रिलेटेड पूछ सकते हो कुछ भी, पांडे सर के बारे में मुझे पता नहीं। केमिस्ट्री के बारे में कुछ भी पूछ सकते हो, एनीथिंग रिलेटेड टू केमिस्ट्री। So why less students? 24 only, 50-60 students were there. Today only 30 maximum. All of you didn't get the link or what? All of you didn't get the link? So please subscribe and share. Okay, सब्सक्राइब कर दो दबा के, लाइक और शेयर सब्सक्राइब कर दो। वी आर टेकिंग दिवाली हॉलीडेज ऑल्सो सर, सो टुडे लेस मेंबर्स। यस, टुडे वेरी लेस मेंबर्स, वेरी लेस मेंबर्स। व्हाई आई डोंट नो। दिवाली हॉलीडेज कब है आप लोगों का? दिवाली हॉलीडेज guys, any other thing you want to discuss? सर आप नहीं घर गए क्या? नहीं, अपन लोग तो दिल्ली गए थे ना, दिल्ली कोटा होके हम वापस आ गए। हाँ, बच्चे नहीं आते तो बच्चे नहीं आते। देखो, मंदा श्राई कृष्णा मंदा। So if students are not there, so we will also decrease our energy. Like if we have 100 or 50 students, our energy is in a different level, right? So you know the reaction, right? A chemical molecule needs some activation energy. Like you know the Newton's second law. Like a body will be in rest. Sorry, first law. A body will be in rest or will be in the motion until and unless a external force is applied. So आप लोग, you are all the external force to me. And yes sir, कल 10 मेंबर था पर जोश बड़ा था। अरे ऐसा नहीं है, अपन हमेशा जोश में रहने की कोशिश करते हैं। कभी कभी कोई एक्सटर्नल फैक्टर भी वैरी कर जाता है, जैसे कि आज अभी तक ब्रेकफास्ट नहीं मिला है तो जाके अभी ब्रेकफास्ट का बंदोबस्त करते हैं, नहीं तो जोमेटो करते हैं। दामोदर सोमा, यस, हेलो बेटा, यस। So hopefully you have physics class right now. It's already 11:17, so you can all go and join there. Okay, hopefully you have enjoyed the one short video. Everyone requested for this, that's why only for 25 member also we did. And you will not get the revision in class. Okay, you will not get this revision. Ionic equilibrium I have taken a lot of time, so you can come personally, but no class, no revision class. You got one short video, everything you got, so no revision class. You can come personally and ask whatever you want. No revision class on ionic equilibrium, never. Okay, so enjoy, solve your modules before coming, or if you are coming today, solve today here. Okay, ionic equilibrium very easy topic. Yes make it do. Ionic equilibrium is very easy topic, just master on your calculation and logarithm. Lakshmi Bhavitha, yes very easy topic. सर क्लास में क्या करोगे? क्लास में इंडिकेटर्स पढ़ेंगे, इंडिकेटर्स, पीएच कर्व, देन नेक्स्ट टॉपिक क्या है आई डोंट नो, बट मोस्ट प्रोबेबली थर्मो और पीरियोडिक। ओके, मोस्ट प्रोबेबली थर्मो और पीरियोडिक, आई डोंट नो व्हाट इज द नेक्स्ट टॉपिक। सो क्लास में करेंगे इंडिकेटर्स और पीएच कर्व, नेक्स्ट क्लास टुमारो। ओके, थैंक यू ऑल, सी यू सून लाइव, बाय। एडवांस हैप्पी बर्थडे सर, पीबीएस चंद्रा कार्तिकेय। अरे मेरा बर्थडे नहीं है, मेरा बर्थडे 32nd को है। माई बर्थडे इज ऑन 32nd, नॉट नाउ। सो सी यू ऑल टुमारो एंड आई विल अपलोड दिस वन इफ एनीबडी हैव मिस्ड और यू वांट टू सी अगेन। ओके, एडवांस हैप्पी बर्थडे। मेरा बर्थडे नहीं है अभी, माई बर्थडे इज नॉट नाउ। थैंक यू फॉर द एडवांस विशेस। कभी तो है। ओके, सी यू ऑल टुमारो, इंस्टा पे 10 अक्टूबर नहीं है, 10th अक्टूबर नहीं है। चलो, सी यू टुमारो लाइव।